Hello guys, today discussing in this video open coiled helical spring subjected to axial load and derivation. See in this video one by one. First one is the open helical coil spring. The terms are defined as D is the diameter of the spring, D is the diameter of the spring here, and R is the main radius, and P is the pitch of the spring here, and N is the number of coils, and G is the modulus of rigidity, W is the axial load here, W subjected to axial load W here. Next one, the consider a spring, one spring, and making angle alpha and torque equal to load into distance here, load W into R, load into distance, momentum equal to load into force into distance, W or sin alpha. Because I am writing cos alpha here, angle making with respect to x-axis is called cos alpha and remaining called W or sin alpha. Consider a triangle from here, consider alpha and here 2 phi r in length and here length L and load is W, and cos alpha equal to, I am writing adjacent side by hypotenuse, adjacent side is 2 phi r in and hypotenuse L equal to 1 by cos equal to secant alpha. I am writing a total length equal to what is total length equal to 2 phi r in secant alpha. I am getting here also, and according to bending moment equation, m by I sigma y equal to m sigma equal to stress equal to m into y by I, m equal to W or sin alpha. I am here seeing in here W or sin alpha, and y is the distance from bottom and top axis from neutral axis here d by 2, and I is the momentum of inertia 5 by 64 d power 4. I am writing here, and solving this value we will get to 32 W or sin alpha by 5d cube. Similarly, torsion equation T by J equal to G theta by L. I am writing theta equal to T into L by Gj, T equal to W or cos alpha into L by Gj or Jg. Similarly, m by I equal to E by R. I am writing 1 by R equal to 5 by L. 1 by R equal to 5 by L. Writing here, and phi equal to m into L, E by I, E into I or I into E. Strain energy stored in a spring under torsion and bending. That means U equal to half of T theta plus half of m phi is the equation number 1 taking. Similarly, U equal to 1 minute. Average load equal to work done equal to formula work done equal to average load into deflection, average load into deflection. I'm writing here half of load into deflection. It is denoted by current U. This is taking equation number 2. Equating equation 1 and equation 2 here, half of the load into deflection, half of T theta plus half of m phi, and half of cancel both sides, and load into deflection T theta plus m phi. Here T equal to W or cos alpha, theta equal to, here we are getting firstly theta equal to W or cos alpha L by G J. I am writing here, and similarly m equal to W or sin alpha, and phi equal to here getting phi equal to m equal to W or sin alpha into L by EI. The term writing here, and multiply here W square into R square L. Similarly here W square R square into L common here, and W square here, 1 W here cancelling, remaining 1 W here remaining, WR square remaining terms cos square alpha by GJ plus sin square alpha by EI. J equal to polar moment of inertia, circular section writing here 5 by 30 d power 4, and similarly I is the moment of inertia 5 by 64 d power 4, and L is the total length of spring equal to 2 pi r and secant alpha. I am getting firstly L equal to 2 pi r and secant alpha. I am writing here again, and solving this term we can get cos square alpha by G plus 2 sin square alpha by EI into 64 WR cube n secant alpha by d power 4. Substituting this value is total deflection of a open coiled helical spring. Substituting in open coiled helical spring alpha equal to 0, then we'll get a closed coil helical spring. Substituting alpha equal to 0, here alpha equal secant alpha equal to secant 0 is 1, and cos 0 is also 1, sin 0 is 0. This total term is 0 here. The term is 0, remaining term is here 1. Then we'll get the open coil closed coil helical spring 64 WR cube n by GD d power 4.